Okay, in this video is going to be activity 5, and it's also going to talk about which stat to use and why. So you'll watch this video right now. You'll need this spreadsheet, okay, which we'll talk about, and then you're going to work on these practice problems afterwards. I'm going to do the first one for you. You can do the other 3 of those, okay? So first idea here is by now you should have an understanding of why we use statistics. So we're looking for a way to disprove the null hypothesis and prove and therefore accept the alternative hypothesis. We do this through calculating p-values and things like that. We're looking for statistical significance. So with that idea, we can talk about data, and there's kind of 2 types, discrete and continuous. Now, for the most part, how we treat that will be more or less similar. Discrete is different values. For example, frequencies, or if you're looking at, somebody's favorite colors. There's not, there's red, green, blue, those sorts of things. Continuous could theoretically be any number. So you're looking at, the height of somebody, that would be continuous. Theoretically, it could be any number. Okay, and that's going to determine where you go. Now, the other second big thing here is this idea of correlations and differences. Okay, so if you're looking for a correlation, does one thing increase when another one increases? Does one thing decrease when another thing increases? Those are correlations. Changing one causes a change in the other. Or you're looking for differences, right? Is there a statistically significant difference between using aspirin and ibuprofen, right? Is there a statistically significant difference between studying 2 hours for a biology exam or 4 hours for a biology exam? And then what the difference is, if you have 2 groups of data, so aspirin and ibuprofen, um, that can be a Mann-Whitney U test or a T test. Okay. If you're looking at 3 or more, that's ANOVA. Okay, and ANOVA can then go and do another one to look for specific differences, but we'll get into that a little bit later. If you're looking for correlations, you got 2 options: Spearman's rank, and this is good if the data is monotonic. So that means it kind of goes up and then levels out, or it kind of starts high, goes down, but it may not be a straight line relationship. If it's a straight line relationship, then it's Pearson's coefficient, correlation. Okay? Um, and the other option is continuous data. And again, same basic ideas here. You can do a t-test. If you have more than 20 data points, Mann-Whitney U from 5 to 20, but to be perfectly honest, that's mathematically speaking, but you could do a t-test with 10 sets of data in IB land. Okay, and if you have 2 or more groups, so if you're looking at the difference between, in this case, say basketball players, baseball players, soccer players, American football players, and how far they can throw a ball, that would be an ANOVA test. Again, here, paracetamol versus aspirin. And then correlations, again, same ideas. It's a straight line relationship or not. So that's kind of how you would kind of choose which ones. To be honest, most of the time you're going to be using ANOVA, t-test, Spearman's rank, or Pearson's coefficient. Chi-squared is a whole different thing. We'll talk about that later. All right, so if that's once you've kind of figured out which stat you're going to use, this this spreadsheet is completely invaluable as long as you do this, okay? So this is a spreadsheet. Now notice right here, right, only add things to the green boxes. Change anything else will break it. That is true. Do not change any of that. So if you looked at like Spearman's rank down here, these green boxes are the only spot you can put data in, okay? We talked about monotonic data, so here's some examples, but if it goes up and then down, it's non-monotonic, and there's not a lot of stats you can do in that situation. Okay, if you want to do a t-test or a z-test, here, Pearson's here, ANOVA's here, and then some other ones which we'll use later with the chi-squared ones. But again, all of these have green boxes. You do not put anything else in these white boxes. It'll break everything, okay? So you can use this, make a copy of it, and then, but again, don't ever put anything outside the green ones. All right, so the next step you're going to do is do some practice problems, okay?